All right, let's talk about trigonometry, specifically one of its trickier sounding functions, the cosecant. Now, I know it might sound complicated, but here's the secret. If you already know what sine is, you're pretty much all the way there. Let's dive in.
So just think about this for a second. We've all got sine down, right? SOH, CH, TOA. Opposite over hypotenuse, it's second nature. But what happens if you just flip it? What if you look at hypotenuse over opposite? Well, it turns out mathematicians gave that its very own name, and that's exactly what we're going to unpack today.
So, the best way to tackle this is to start with something you already know cold. We're not learning some brand new, scary concept from scratch. We're just looking at something familiar from a slightly different and really useful angle. Okay, first things first. Let's get our bearings with sine. Remember good old SOH? Sine is the SOH, the ratio of the side opposite your angle to the hypotenuse. This simple little fraction is the bedrock for everything we're about to do.
And bam, meet cosecant, or CSC for short. Just look at the screen. It's the literal, mathematical reciprocal of sine. It uses the exact same two sides of the triangle, just flipped. That's why I like to call it sine's upside-down twin.
Now this is where it gets really useful. This relationship isn't just about triangles, it's algebraic. We can just say that cosecant is 1 divided by sine. And this is a total game changer, because your calculator probably doesn't have a cosecant button, right? But it for sure has a sine button. So if you need the cosecant of, say, 30 degrees, you just punch in 1 divided by sine of 30. Simple as that.
Okay, here's a neat little fact about cosecant that you can use as a gut check on your answers. In any right triangle, what's the longest side? Always the hypotenuse. And since cosecant puts the hypotenuse, the biggest number, on top of the fraction, the result is always going to be 1 or bigger.
Pretty cool, huh?
Okay, enough with the theory. It's time to actually get our hands dirty and see how this thing works in the wild. Let's solve some actual problems.
So, let's take a look at this first example. Super straightforward. We need the cosecant of angle A. First step, find our sides. From angle A's perspective, the opposite side is 5 and the hypotenuse is 13. Next step, build the ratio. Cosecant is hypotenuse over opposite, so that gives us 13 over 5, and that's it. That's our answer.
All right, check this next one out. It looks more complicated, but it's actually way easier. If you're told the sine of an angle is 7 over 8, what's its cosecant? You don't need a triangle, you don't need Pythagoras, you don't need anything except that one core idea. Cosecant is the reciprocal of sine. So you literally just flip the fraction. The answer is 8 over 7. Done.
Okay, let's up the difficulty just a notch and work backwards. If the cosecant is the square root of 2, what's the sine? Well, first step is the same. Flip it. So sine is 1 over the square root of 2. Now, technically that's correct, but in math, it's considered good manners to not leave a square root on the bottom of a fraction. So we do something called rationalizing, which is a fancy way of saying we clean it up. We multiply the top and bottom by the square root of 2, and we get our final polished answer, the square root of 2 over 2.
All right, I'm going to pause here for a second because I want to talk about the #1 trap that students fall into with this stuff. Seriously, if you remember this one thing, you'll save yourself so many headaches.
It's the name, cosecant and cosine. They just sound like they should go together, right? Your brain is screaming to pair them up. It feels right. But nope, it's totally 100% wrong. Cosecant is not the reciprocal of cosine.
And this slide says it all. You just got to burn this into your memory. The names are kind of counterintuitive, I get it, but the correct pair is always cosecant with sine. That's the rule. Cosecant goes with sine.
But hey, I'm not going to leave you hanging. Here is an awesome little trick to remember this forever. Just think, in every correct reciprocal pair, there's exactly one co. So you have sine and cosecant. You have cosine and secant. One co per pair. If you remember that, you'll never, ever mix them up.
So, at this point, you might be thinking, okay, I get it, flip the fraction, but why? Why do we even need a whole new name for this? And that is a great question. Let's zoom out and look at the bigger picture.
The honest answer is that sometimes flipping a fraction is like a secret key that unlocks a really complicated problem. These reciprocal functions, like cosecant, are crucial in really advanced fields like rendering computer graphics, doing high-level calculus, and processing signals. In electrical engineering, for instance, they use the reciprocal of resistance to make solving parallel circuit problems way, way easier.
So, we've seen today that just flipping sine upside down gives us this whole new powerful tool called cosecant. And that kind of begs the question, right? If flipping sine is this useful, what happens when you flip cosine? Or tangent? What other cool stuff can we unlock? That's something to chew on for next time. Thanks for joining me.